Today's lesson is 5.3, Special Right Triangles, 45, 45, 90. We've been looking at the Pythagorean theorem to help us solve the missing side of any right triangle. What people started to notice after the Pythagorean theorem is that there are a couple of special right triangles, the first of which we're going to look at today, the 45, 45, 90, that create a ratio amongst the three sides that always holds true no matter what number you use. Now, a 45, 45, 90 is by definition an isosceles right triangle because I have two of my base angles that are equal, making the two sides equal as well. So whatever those sides are, they are always the same. And if you notice, these are the two legs of your right triangle. So let's go ahead and label them as such. And of course, then they started to notice that anytime that the legs were the same, notice A and A. I'm using the letter A so that it could be any number. And it's because it is the same letter, the same variable, it has to be the same number when I substitute in for one of them. And then, of course, the other side is my hypotenuse. So let's just label that. And what they noticed about the hypotenuse is that it's going to be whatever that A value is times the square root of 2. It's going to be A times the square root of 2. When we go in to do our problems, it is very, very important that you label, label, label. You do not need to label the words leg, leg, hypotenuse, but you need to know what you need to make sure you label is that you can find the two legs. Find the two legs. Remember my trick, they both have the 90 degrees, and you're going to label them both with the variable A. Then you're going to put the other side, the hypotenuse, and remember my trick for finding the hypotenuse, it doesn't have the 90 degree at either end, and you're going to label it A times the square root of 2. Remember the times is hiding in there. Very, very important that you label, label, label. Let me change my color for the labeling, and let's go ahead and get started with our first example. So here is my 45, 45, 90 degree triangle. Notice I only put one of the 45s in because it's implied that the other one is as well. I could quickly do the math. 180 minus 90 equals 90. And 90 minus 45 gives me a 45 degree at the other angle. So it's not necessary to add it, but it is there, okay? All right, let's find our legs and label them with the variable A. So here is a leg and here is a leg. So I'm going to go ahead and label both of these as A. Okay, and then I'm going to take the side that is missing, the hypotenuse, right? Take a look at it. Here's my trick, no 90 degrees. And I'm going to label it as A, the square root of 2. And if you want to, you could put a little times in there. Okay, now what I'm going to do is I'm going to find where they gave me the number. I must give you a number, okay? I must give you a number on the side. Notice I gave you a number right here, 3. So I'm going to go ahead and I'm going to circle that along with the marking that I gave, and I'm going to put an equal sign in between them. What I'm basically telling you is that the variable A for this triangle equals 3. That's what this is saying. So all I have to do to find X and Y is to plug in that value for the variable A. Because right here, X is going to be equal to A. So that means X equals 3. That's it. And right here, I'm telling you that the variable y is equal to a times the square root of 2. You plug in the 3 for a, and you put the square root of 2 after it, and you leave it. That's it. Those are your answers. Okay, so we start off with the nice easy one. I gave you a, you plug it in. All right, let's try some harder ones. Let's try some harder ones. So take a look at this triangle I have up here on the top. Notice I have labeled it as 45, 45, 90. I have everything in there. I'm going to go ahead and I'm going to find my legs. So I find my 90 degrees, and here's a leg, and here's a leg. Uh-oh. I'm going to label them both as A. Okay, I know you heard my uh-oh, but we're just labeling right now. And then my other side right here is my hypotenuse because there's no 90 degrees. So I'm going to label that as A, the square root of 2. I'm going to find the number that was given to me. One of these three sides must have a number. The other two will either have a variable like x and y, like you see here, or they will just be blank. Here is the number that they gave me. So I'm going to circle these and set them equal to each other. I'm going to circle these and set them equal to each other. And I'm going to remind myself that there's a multiplication in there. All right, I have to do a little bit of work first. I'm going to change my pen color. I'm going to come over here and I'm going to say A times the square root of 2 is equal to 10 times the square root of 2. Okay? Remember, we want to get A by itself because I want to know what the variable A equals. Because if I know what the variable A equals, I know what Y equals, and I know what X equals because that's X and Y are both A. Okay, let's think. The square root of 2 can be pretty scary, but don't think of it that way. You're multiplying the variable A times the square root of 2. How do you get rid of times? You simply divide. So if I divide this by the square root of 2, it disappears. What I do to one side, I do to the other. And take a look at this. It disappears as well. And A is equal to 10. A is equal to 10. So now I can come back and I can say X is equal to 10 and Y is equal to 10. Because they are both simply A. That wasn't so bad either. Maybe this isn't so scary. Let's take a look at this next one. 45, 45, 90. Let's label them A, the square root of 2. Find your 90 degrees. These are your two legs. You're going to label them both with the variable A. Okay. The third side is your hypotenuse because there's no 90 degrees, and you're going to label it A times the square root of 2. You're going to find where they gave you the number. They gave me the number right here, and you're going to circle it, and you're going to put an equal sign in between. Now, wherever I see that teal A, I'm going to plug in the number 2 times the square root of 3. Okay, so let's start. I know normally we start with X. Let's start with Y. Okay, let's start with Y because take a look right here. Y is equal to A. Y is simply equal to A. So A is 2 square roots of 3, and I'm done with Y. X is going to be a little bit trickier. X is going to be a little bit trickier. I'm actually going to have to do some work. Okay, so I left some space up above so I can actually do my work. Now, take a look here. X is equal to A times the square root of 2. So let's change our pen color here and let's do some work. Right? This is what it says down below. Okay? I know that A is really 2 times the square root of 3. Right? Square roots work just like variables. So x times x is x squared. So what I can do here is I can keep the 2 in the front, and I can actually multiply the 3 times the 2. Oops, that should have been a 2. Sorry, guys. The 3 times the 2 that are under the same square root. Anytime that you multiply a square root times a square root, you can do this. You can put them together under the same square root. So now I know my answer. It is 2 times the square root of 6. Okay, that one is probably one of the trickiest ones. Okay, last question, last example for today. Go ahead and find your values and or find your legs and label them as A and A. So find the 90 degrees and those are your two legs. Label them A and A. And then your third side is always the hypotenuse because it has no 90 degrees and you're going to label it A times the square root of 2. Go ahead and find where the number is given to you. That would be the 4 at the hypotenuse. Circle it and what you just wrote and set them equal to each other. We're going to have to do some work. This says A times the square root of 2 is equal to 4. That is what this equation says. Let's solve because I want to know what A is. Once I know what A is, I know what X is and I know what Y is. Here we go. Just like before, just like in the previous example, we're going to go ahead and divide by the square root of 2. But notice what happens on this side. This time it doesn't cancel out. This time it's not canceling out. Don't worry. What we're going to do is called rationalizing the denominator, which means you're going to take the denominator of the square root of 2 and make it into a fraction over itself, just like so. You are now going to multiply in the normal way that you would multiply fractions, which is numerator times numerator, top times top, bottom times bottom. Okay, you're no crisscrossing, no crisscrossing. The normal way you multiply fractions. Numerator times numerator, denominator times denominator, top times top, bottom times bottom. Let's go ahead and fix up that bottom because we just talked about it. Okay, the numerator stays the same, but the denominator I can think of as 2 times 2 all under the square root. Well, I know that the square root of, or I know that 2 times 2 is 4. And guess what? I know that the square root of 4 is really 2. Right? I know that the square root of 4 is really 2. That's what I did. This right here is equal to 2. And then I know that 4 divided by 2 is really just 2. And then the square root of 2 doesn't go anywhere. So A is equal to the square root of 2. And my X, let me see, where can I put it? X is equal to 2 square roots of 2, and Y is equal to 2 square roots of 2, because they are both A.